Um, okay, these are the notes. You should have a yellow paper that says topic lesson 2 groundwater versus surface water. Um, this is kind of long, just warning you. So you might want to write small. Um, if you forget anything, you can always add it back in or like staple a piece of paper next to it. Okay. Like when you come up and check the key and make sure that you got everything. You know how you do that every time we take notes? Okay. So we're going to talk about surface water and groundwater. Um, do we care about groundwater or surface water? Should we care about groundwater or surface water? So you probably don't care about this water. If someone came up to me at a party and started talking about this, I would leave. I would walk away after being super nice about it, though. Unless I was actually listening, because this is really awesome. And the more I learn about this, like the more amazing it is. And I hope that you have the same feeling about it because it is amazing. And Austin, where we live, is amazing. Okay, so what is surface water? Surface water is streams, rivers, lakes, and reservoirs. Okay, so streams, surface water, we all know what it is, right? Groundwater, we can't see. Excuse me. So it's a little different, but surface water, we all know what it is, especially y'all, because you live on the lake, right? And that's surface water. So all of these pictures are taken in the Barton Creek Greenbelt, all of them. This. In fact, I was just here the other day and I got lost and I fell. So streams, rivers. This is the Grand Canyon. Oh, I forgot what river that is. I don't remember. But it is, you can really tell that it has shaped the land around it. Lakes. Here's the Great Salt Lake. This is Lake Tahoe. I believe this is Lake Travis. Looks like it with all that limestone. Reservoirs. So some reservoirs are lakes. Lakes are not always reservoirs. If it's a natural lake, apparently it's called a lake. If it's not, it's a reservoir. But in Texas, we call them all lakes, right? We don't say that we live at Lake Travis Reservoir, even though technically it is. So they look really different. This is a natural lake. This is Lake Tahoe. Here are the lakes. We only have these lakes because of the dams. And you can see all these dams. I thought this was kind of a neat picture. Mansfield Dam is the biggest. This is a picture of it right here. So it's pretty cool, I think. And this big bad dude is the Hoover Dam. Okay. So, and it makes Lake Mead in Nevada and New Mexico, Arizona and New Mexico, sorry. And this is a road, like you can see how big this is. These are cars, right? You can see how enormous this thing is. And it's not a natural lake either. Okay. Okay, so we have chemical weathering that happens with surface water. So rainfall and surface water percolate through the joints in the limestone. This is all considered surface water. And then when you have an exposed carbonate surface, it can make like a pond and it can create wetlands. That's what dissolution is. Usually when we talk about dissolution, we talk more about the groundwater and dissolution. This up here is a really good example of oxidation, and you can tell because it's red. So there has been some oxidation happening here where the iron in these rocks has reacted with oxygen in the atmosphere. Also, we have freezing, abrasion. So I think normally, most of the time when we talk about how how surface water weathers rocks, we are going to talk about physical weathering. Okay. And so here's a couple kinds of that. So we have freezing. That's when like water comes in here and freezes. We all know that water expands when it freezes. And so after time, it breaks all this up. Right here, the mechanical action of rain can work on the gray, like right here. And so these are two different kinds of rocks, and just they have different properties. So it's going to be weathered differently. Okay. And I'm sure you guys have seen stuff like this. If you're on like a big road trip, look out the window and see like this, especially if it's anywhere in the West. Also, we have abrasion. This is usually like with glaciers. Glaciers are considered groundwater, and they, like when these rocks that are underneath here, they get kind of scraped, and you can really see, like one of the signs of a glacier is you can see scrape marks on the rock. So freezing and abrasion and impact raindrops are examples of physical weathering by surface water. This is surface water physical weathering. Okay. So this water carved the Grand Canyon. My mom always told me that. She'd always say, the Colorado River carved the Grand Canyon. This is not the same Colorado River that we have running through our beautiful city. It's a different Colorado River. I don't know why we chose to call it the Colorado River too. Maybe we did it first. I don't know. But this is the Grand Canyon. You can see that it used to be different, right? There used to be water over here, and we can tell because of the canyon. But all of this is just formed by the water carving away the rock. And one interesting thing about the Grand Canyon is that the water didn't carve it down. Remember we talked about uplift the other day when we were talking about actually I don't know that we talked about that. We talked about the Llano uplift, and the land that the Grand Canyon is on lifted up, and the Colorado River dug down in it. So kind of cool. So it didn't sink this. The rock and stuff rose up around it, and then it carved it. Here is some more chemical weathering. This is an example of freeze thaw. Okay, and you really need to know, it's in our teak, water, fresh groundwater is a serious natural resource. It is required for living things. We have to have it for agriculture. Otherwise, we'll be like the people in Interstellar. Sorry, y'all. It is Friday when I'm making this video, and it's late, and I want to go home. So we use it a lot for agriculture. All of our food is grown by this. Hydropower generation, we make a lot of that. We like our dam here, Mansfield Dam, makes power. Very clean, great way to use the water to make our energy. Transportation, you guys will notice, I love talking about this, but big civilizations, the big cities in the United States, they are on water. Even Chicago, it's on the Great Lakes, and it has a river that goes out to the ocean. And that's because we use it for transportation of our stuff and ourselves, right? And of course, it's a habitat for a lot of ecosystems and recreation, of course. So here are some landforms created by surface water. Valleys, of course, fjords. Y'all, fjords are really cool. I know that I've told y'all that I'm Norwegian. I always thought that Norway was the only place in the world where you could see a fjord, but there are more. There are some in the United States, and I think they're up by the Great Lakes. But they're really cool. They're just like these inlets here. Really neat though. They're really wide and like, I don't know, they look like this. They're beautiful. Can you imagine seeing like the Northern Lights up there? Pretty awesome. Also, if you've seen the movie Frozen, you heard Elsa and Anna talking about the fjord, right? Let's see. These are canyons, right? Here's the Grand Canyon, which we talked about before. So pretty. And this is Palo Duro Canyon. Isn't that gorgeous? Actually, y'all, I think this is Palo Duro Canyon. Man, I wish I had made this video right after I made the slideshow, but I know for sure this is Palo Duro Canyon. Pretty awesome. I've never been to Palo Duro Canyon. Did you know that it's the Grand Canyon of Texas? Okay, another thing we got to talk about is Niagara Falls. So waterfalls. I don't know if y'all have ever been there. It is amazing. So here's like an satellite view or maybe an aerial photograph of Niagara Falls. Okay, so this is it right here. Okay, obviously this is weathering. Like there is a difference in the height here, and all the water just spills over the side. It's huge and it's beautiful. And I believe that like this is Canada and this is the United States. Not positive about where all of that starts and stops. Let's see. I thought I had something else about that. No. Let's see real quick. Sorry. No. Man. Okay. But that's really cool. And that's still eroding. Like I read a book called like After Us or something, and it talked about like what will happen to Earth when we're gone, and it gave a timeline for when Niagara Falls would be like completely eroded, and it wasn't all that long like in geologic terms, but it was pretty cool. So this is actively eroding. Okay, then we have groundwater, and y'all, groundwater is really cool. I know that you've heard me talk about the aquifer. It is so cool. Way cooler than you would ever think. Okay, so groundwater is just fresh water from rain. It's usually melting ice and snow that seeps into the soil, and it is stored in the tiny little spaces between the rocks or within the rocks. It can also be stored in soil. I know in Houston, they always talk about like the water table, which is right here. Also, I used to live in South Carolina, and you couldn't. Actually, that's a terrible example. Never mind. But the groundwater basically just fills all of these little spaces up, and it's stored in there. 95% of our fresh water in the United States is groundwater, which means it comes from aquifers. Pretty awesome. So let's see. Here would be, so what this picture is showing us is that when we use, or with this water down here, it's been down there for thousands of years. So when it comes out in this stream, it's kind of a mix of all of these different ages of water, but it's probably pretty clean. Okay. And it's clean because it gets filtered through all of this limestone. Okay. So we live on top of a karst aquifer, which is just a limestone aquifer. I know we talked about the Balcones Fault and the Balcones Escarpment, and I know I went on and on about it, but it's really cool. So this here, this is like what we look like, right? This is all limestone here, and this is just like a layer. There's obviously some layers in it. And within this limestone, there have been some places carved away, right? We have lots of caves under here. If y'all have ever been to Inner Space Cavern or Natural Bridge Caverns in San Antonio, we have a lot of these because the limestone does get eroded. So, and it holds water. So let's see. Springs is where it comes out. And I've also talked at length about Barton Springs. So that is like an exit for the water. We have a lot of entrances for the water. We have sinkholes, karst window. That's how it comes in. You guys read that article about the Balcones Escarpment, and it said that that's how the water gets into the aquifer. So that's basically what this is. This is like the escarpment, the Balcones Escarpment. We also have a lot of caves, and Mr. Loomis was just talking about when I showed that picture of Barton's Springs pool, he said that there's a cave entrance under the diving board, which gave me a little anxiety, but that's crazy. Like there are caves all over the place. I can walk to a cave from my house. Pretty awesome. I don't go in it though because I'm scared. So there's lots of different kinds. I'm sure you guys have seen this sign, right? Entering Edwards Aquifer. You see it like on the bridges and stuff. And so we live in the recharge zone, which is this light blue area here. Okay. And there's also the contributing zone. So all the rain and stuff from up here comes down here and it's recharged. This little tiny area is the transition, which basically runs right through us. And then we have what's called the artesian zone. And if any of y'all are going to be going to Texas State, which I'm sure there's a lot of you guys, it's like right here. That's why that river is so beautiful. It's a spring-fed river, and it's just beautiful, clear water. It's all part of this. It has been filtered by the limestone. Also, just want to show you the reason that they show us this is, and the reason that it's environmentally sensitive is because, like, let's say you had a whole bunch of oil or something, or like you had a big truck full of like some disgusting chemical, like fertilizer or something, and it spilled on the highway. That highway, if it's part of the recharge zone, it could get into our water supply. And while it is filtered, we also get some not non-filtered, but we get some water that hasn't been filtered for, thousands of years. So we have to be careful here. Also, there has been a lot of talk. I have a friend that is she used to work for the Sierra Club, but she's an environmental attorney for the city of Austin. And she tells me all the time that like the houses like in Dripping Springs, they're building tons of houses. They're building tons of houses out here too. But specifically Dripping Springs is a little south and it's more like down here. We're kind of up here. I think we're a little bit more out of the zone here in Lakeway. City of Austin is absolutely in the zone. I'm not sure why that doesn't go up there. But all those houses are being built like right here. And that's terrible because just people being there and us driving and, spilling stuff and having, plumbing and waste, all of that stuff, it ends up in the aquifer. So the more people live up here, the less water we have and the more contaminated water we have. So that's why people are against like development. So it's not because they don't want people to live here. It's because we want to have clean drinking water. So I don't know that there's really a solution to that though. Like people have to have a place to live. So okay, we have a lot of chemical weathering with groundwater. Okay, so we have dissolution. It's similar to surface water, can lead to the formation of caves, sinkholes, and entire underground drainage systems in limestone. Like Austin. I'm just putting this all out here so you guys can get it down, and then I'll kind of move on so that you can have this written down. Hydrolysis, this is very vague. We're not going to talk too much about it, but the water reacts with minerals. Acidification is hydrolysis, but the water becomes acidic. Our water is acidic because of the limestone. Okay. It forms acid, and then it dissolves the limestone, and it makes these awesome caves. Then we have physical weathering. All of this stuff, the rocks expand when they absorb and release water. This also says dissolution. I don't know how dissolution is physical and chemical. And then hydraulic fracturing. Sometimes, even if it's not frozen, just the pressure of moving groundwater can force its way into cracks. Also, some things we want to consider. Groundwater has less oxygen than surface water, so oxidation is less prominent underground, so we get less of that like rusting. And everything with groundwater is a slower process. Like Niagara Falls, that is happening at a lightning speed compared to Barton Springs. Okay, like everything is much slower underwater or underground. Okay, let's talk about caves. Caves are awesome. This is Inner Space Caverns. This is Longhorn Cavern. I believe this is also Longhorn Cavern, or this might be Wonder Cave. This is Enchanted Rock. So we have karst topography. And so the dissolving of this limestone bedrock has made all these sinkholes, sinking streams, caves, and springs. It only happens in limestone areas, like where we live. And only about 20% of the US is karst topography like this. So we're really special, guys. The limestone dissolves. It doesn't take a lot. Doesn't have to be that acidic to dissolve limestone. Enchanted Rock is so cool. So remember we talked about the Llano uplift, and that land lifted up and there was limestone on top of it, like there is all over the place and all around it. But it dissolved. And so now what's left is granite. And this is pink granite, just like the Capitol is made out of. This is where all the springs come from. I know we talk about Barton Springs a lot. There's a lot of springs down in New Braunfels and San Marcos, Ocarina Springs. The limestone covering dissolves on top of the springs, and then it has an exit. Barton Springs is one of the main discharge points for Edwards Aquifer. And Edwards Aquifer is extensively faulted, and it has a lot of fractures and caverns, and it's in the Balcones Fault Zone, of course. That's why we have all this stuff. So not only do we have karst topography, but we're also in this fault zone, which is one of the reasons why everything here is so cool. I mean, look at this, guys. That is gorgeous. This looks like bacon, doesn't it? And this looks like drinking straws. This is called the Devil's Sinkhole. Look it up. This is a human, like a full-sized human standing on this. And this is a cave. Here's the top is a sinkhole. This is just west of San Antonio. Also where the Llano uplift is and where Enchanted Rock is. But I mean, look at that. That is really cool. You don't see stuff like this unless you go on vacation, and we could drive for 30 minutes and, well, maybe a little longer than that, and be there. It's amazing. We just talked about this, but I just wanted to show you this map, basically. So we have this recharge zone, and then over this, these are, like these red lines are major faults. And this came from a San Antonio newspaper, so they're not really showing us a whole lot of love up here, but they do extend up here. But you can see kind of, it's not like it's one big crack, it's a whole bunch of small faults. Like if you were to break apart like I'm trying to think of something like a gooey quesadilla or something. I don't know. Also, just wanted to remind you, remember that little pink area right here? That's what this is. That's the Llano Uplift, and all the limestone dissolved, leaving the granite. That's what Enchanted Rock is right here. I know, it's amazing. Okay. This is all, this is the Llano Uplift, and not very far from us is Marble Falls, right? So this is all just west of us. And remember, east of us is farmland, right? It's like Houston, that silty, low-lying farmland. Inks Lake is gorgeous. You should go look. It is a whole bunch of granite, pink granite. All of this up here, it's really beautiful. Here's Enchanted Rock. And that's it. I don't know what else to say about this. It's so cool out there. And again, here's the Llano Uplift. We are on the edge of the Edwards Plateau. Okay. So we're kind of like the prairies. Yeah, Texas is awesome. I guess that's it. Please make sure that you write your summaries at the bottom of your paper for both surface water and groundwater. And please check the notes so that you can make sure you got everything that you need to know. That's awesome. That's it. And thank you for listening to me go on and on about the aquifer and the Balcones escarpment. These things are super cool. Okay,